specifically?
Specifically, number 19.
Number 19. Yeah, this one is not complete. This one is supposed to be orbitals are the solutions to the what are the orbitals the solutions to? Where do orbitals come from? The solutions would be like the answers to what?
They help describe different levels.
Well, the solutions would be like a mathematical solution, you know. So the orbitals, if you fill in the blank, it should be are the solutions to the Schrodinger equation. The Schrodinger equation is the equation of quantum mechanics. The orbitals come from quantum mechanics. Orbitals come from the Schrodinger equation. And there's certain mathematical restrictions to the orbitals make it. So, for example, if n is equal to 0, that's what we call forbidden because it doesn't answer the Schrodinger equation. It fails the Schrodinger equation. So there are allowed orbitals and forbidden orbitals. The Schrodinger equation tells us what are allowed, what are forbidden orbitals.
Can we go through this as like review? That's so like review day.
All right, we can do that. Did you guys work through it, or did it pretty much? Yeah. Right. Yeah. You know, originally I was thinking that we need a serious mock test, but I've been receiving a lot of requests for the answers for this. The original thing was just looking up the answer is a very good learning process. And so, anyway, 1, 2 are from the last test. Although we didn't complete all the reactions. So 1, 2 should be from your exam 2, stronger oxides, weaker oxides, driving force for what? Double replacement reactions? False. Metathesis reactions consist of favorable ion combinations? True. A mole of carbon, that's from exam 1. A mole of carbon, or exam 2, I don't know. So this is old material. A mole of carbon 12 atoms weighs exactly 12 grams. That's true by definition. If 2 grams of hydrogen is allowed to react with excess oxygen, that should be O2. O2, then 2 grams of water is produced. Is it true or false? It's false. This is called the mole ratio. It's not the mass ratio. If this is the mass ratio, 2 moles of hydrogen weighs 4 grams. 1 mole of oxygen weighs 32 grams. 2 moles of water weighs 36 grams. So, if this were a mass ratio, this would be 4, 32, 36 in terms of mass. But this is a mole ratio. Mole ratios are the same as volume ratios. Is that true or false? Mole ratios are the same as volume ratios. This is from yesterday. It's true. For gases only, right? Not for. And so this would be like 2 liters, 1 liter. It's no problem. But this would not be 2 liters. So if I said if 2 liters of hydrogen is allowed to react with excess oxygen, 2 liters of water is formed. That's false. Well, this is from earlier stoichiometry. Like I said, this summer it was all mixed up, because of the time. It's so short.
So I know you said like on the test it's going to be starting from chapter 12. Theoretically, the other stuff was not.
Not chapter 12.
Chapter 11. Sorry, chapter 11. the theoretical yield and percent yield and all that stuff was
Not cut.
Wasn't covered to do chapter 11 and 14, so is that going to be a test?
Oh, yeah, wherever we left off should be on the test. What did we do? We just did the first half of the stoichiometry, or did we do any stoichiometry? I thought the stoichiometry we hadn't covered on the last test. The last test we just went up to the gases, right? Did we have a stoichiometry? But we didn't have a chemical reaction stoichiometry problem on the last test. If you look at the stoichiometry, it wasn't really a stoichiometry. It was a gram to mole, mole to number conversion. That was an earlier chapter. There was not a limiting reagent. There was not an excess reagent. There was not a theoretical yield. There was not a percent yield problem on the last test. So it's going to be on this test. And so the material that's going to be covered on this test is going to include that. That's chapter 10, I think. Let me just double check.
It's also from 11 to partial 14.
Yeah, chapter 9 was the last, on the last test we did up to chemical reactions, right? And then we stopped. And then chapter 10, this test is going to be chapter 10.
Third part of chapter 14.
Through part of 14. So it's going to be exactly. Chapter 10 was the stoichiometry.
Yeah.
So, yeah, all of 10. And then, not all of 14. If we look at 14, we're not going to have the stoichiometry, the gas stoichiometry in 14. So we're just going to go to molar volume. Molar volume. 14, section 14.7. So you'll have to use the ideal gas law to do some calculations, either for a single variable or for density or for molar volume. Molar mass, I just drew that. But we had a molar volume calculation, we had a density calculation, and we had a single variable calculation. Molar mass I threw in there, but there's no example of a molar mass calculation. Right? Okay. So 4 is false. 5. The theoretical yield for reaction was 98.3 grams. The amount actually obtained was 91.5. So they lost a little bit. They lost, a little less than 7 grams worth. That happens, chemical reactions. When you actually do, this is what you calculate, and this is what you actually get. You're supposed to get this, but we lost some. So the percent yield is how much do you actually recover. So what did you get in this one?
I got C.
C.
I divided 91.5 by 98.9.
Yeah, that's correct. So you take your actual yield divided by the theoretical yield times 100%. That sounds 93.1%. Definitely not 91.9, not 91.5, and not 98.3. C is the correct answer. What ions are present in what ratio in a solution of, and in what ratio in a solution of aqueous calcium chloride? What's the formula for calcium chloride? CaCl2. Which one did you put? You put C. C is correct. What's the name of this? I don't know. This doesn't make any sense. What is these? These are all bizarre ions. weak acids or weak electrolytes? That's true. HF is completely ionized in water. False. HF is a weak acid. Even though it's a weak acid, it's very dangerous acid. HF is one of the most feared acids around because of its metathesis property. Which of the following substances will precipitate from? Okay, this is a weird wording on this one. Which of the following substances will precipitate from an aqueous solution? That's supposed to be an aqueous solution. Sorry, not. So, in other words, which of these are insoluble in water? It should be group 1 salts are all soluble. So A and C are soluble. Ammonium salts are all soluble. B is soluble. Acetates are all soluble. E is soluble. That only leaves. Carbonates are insoluble except for group 1 and ammonium. So copper. How would you name that? CuCl3. Copper 2. Carbonate. In the combustion of methane, according to the equation, so I gave you the balance equation for methane combustion. How many grams of water are formed during the combustion of 4.24 grams of methane? So, just a little pipe here. But anyway, this is another type. This should be 4.24 grams of methane. But you know, my vision, I need to blow these up bigger. Sometimes I can't see very well. But anyway, 4.24 grams. So what do? We do grams of methane to moles of methane to moles of water, and then moles of water to grams of water. So did you get the answer for this one?
I don't see the value right now.
Okay, yeah, we can see it right now. You know what's often done on standardized tests?
What?
On standardized tests, they don't give you enough time to finish the test, basically. And so you start to run out of time and you still have questions left over to do. They never give you enough time to finish the test because they want to have it, you know, where, you know, they don't, if a lot of people are finishing the test, they made it too easy. And what that does is it doesn't spread out. What they were trying to do on standardized tests is they're trying to spread out all the students. So if they have a cluster of students at the top who are finishing the test, right, and getting hundreds, then they don't know how those students perform. And so what they try to do on a standardized test is make it way too hard so that everybody gets spread out. And nobody finishes. That's ideal, because if nobody finishes, nobody's hit the limit. Because let's say the ceiling's too low and you hit it, you don't know how much higher you could have gone, right? And so one of the strategies that people do for standardized tests is they just do ballpark, you know? Like a ballpark would be like this: 18 divided by 16 is about 1, a little bit more than 1. You know, 4 times 2 is about 8. So my answer is going to be a little more than 8. And then I look over here. My answer is a little more than 8, which only gives me one choice. Right? And then I just saved all the time of punching it in the calculator. This is one of those tricks that are used. But, you know, the makers of standardized tests are aware of these tricks. So sometimes what they'll do is they'll put a cluster of answers
That are like nine.
that are very close, forcing you to do the calculation. But sometimes they don't. And so you usually look at the answers really quick and then see. You know. This is a strategy because there are a lot of standardized tests out there. Well, which one do you think it's going to be for mine? E. E's correct. It comes out to 9. Well, I did this. I just did it. Mine was 9.52.
Yeah, but I think it's a round off pair with oxygen, possibly. If you got an oxygen 16.00.
Yeah.
Charge
Yeah.
16.99.
Right. I got, you know, I get these out, sometimes I get these out of a book, like our book, you know. Our book is notorious for rounding off everything. They do all kinds of intermediate round off here, round off there. They love to round off everywhere. I try to avoid rounding. But I do. I mean, I also use oxygen as 15. I might have been the guilty party here because I like to use oxygen as 1600 rather than 15994. I mean 9994. You know. And so either way, it's within round off error. I don't sweat it. You know, if it's 951, 952, I think it's within round off error. So it's all right. Really, that's what you're going to notice, because even with these periodic tables, you'll see some variation in masses, depending on how they're rounded. All right, so the answer is E for this one. Let's go on to the next one. PCl5 can be produced. What's PCl5 called? Tetra's 4. Penta. Yeah. Phosphorus pentachloride. 2 words. Pentachloride's all one word. Phosphorus pentachloride can be produced by the reaction of PCl3. PCl3 is called phosphorus trichloride plus Cl2 is called chlorine. So that reaction. What mass of PCl3 must be used to produce 127 grams of PCl5? Percent yield is 84.8%. So this is a test of your dimensional analysis skill. If the percent yield is 84.8%, that means we're going to lose some, and we're going to anticipate loss. So that means we have to make extra. And so if we want, if we want 127 grams, and we're going to lose some, we're going to lose about 15.2%. If we're going to lose 15.2%, we got to make more than 127 grams, right? Not less. And so one of the things, well, if we got to make more than 127 grams, well, we'll do that.
So the 127 grams is the actual yield?
The actual yield. This is what we want to produce. The actual yield. So did anybody get this one? Why don't you try to work it out, this one? Try to work it out and see.
Dimensional analysis, so we can just like use the percent yield equation and just plug the variable in.
Either. You could use, you could do it as 2 steps. One would be the dimensional analysis and the other the equation. Or first you do the equation and then dimensional analysis. And so if you use the equation first, it's like this. If you need, let's say, 100 cookies for an event, and you anticipate on eating 5 of them, you're going to have to make 106 cookies, right? And So we could do that step first. If you need 127 cookies and you anticipate you're going to lose some, how many do you have to make? And so that's the step where you can do a separate equation. The separate equation would be the percent yield equation. The other way I would have done it is dimensional analysis, but why don't you try it first? Just do this calculation, since this is usually what I do